Hello. Hi, everybody. Welcome. Hopefully not too many of you just watched us do this over in the other building right before this, because if you did, it's going to be largely the same. But if you didn't, we're going to be running through basically what's new with machine learning in Snowpark here. There are a lot of exciting product announcements this morning. Obviously, I don't know if anybody was doing an ML AI, Gen AI, LLM like word count, but if you were, you probably got pretty tired of it because there was a lot of it, but we're going to keep it going anyways today. It's very exciting, a lot of cool stuff to talk through. We are going to be doing another deep dive version of this session as well tomorrow afternoon, where we'll get to go into a little bit more detail in addition to the demo. Venkat Krishnamurthy is one of our PMs for machine learning and AI on the platform side, specifically ML Ops. He will be joining us shortly, and we will make ourselves available for questions after the fact if there's no time to do it during the session as well. My name's Baechtold. I'm one of our machine learning and AI field CTOs here at Snowflake, working with customers to help them understand how to build, develop, deploy, manage machine learning and AI capabilities on Snowflake, predominantly with Snowpark, but also now Snowpark Container Services and all kinds of other good stuff. So we'll talk a little bit about just the kind of data cloud for AI and ML, what kind of motivated the development of some of these new features around Snowpark ML that were announced by Christian this morning, do a brief kind of dive into that, and then go through an end-to-end demo as well. So for AI, machine learning and AI, there's really, I think, three intertwined, related kind of workflows to go through the end-to-end path through production. And the productionization and operationalization of machine learning and AI is predominantly the gap that many customers and organizations fail to solve. Each one of these kind of phases in this life cycle has its own set of challenges, from the development, compute associated with just building these capabilities, the operational management of those, going from registration, versioning, monitoring, deployment, orchestration, all that kind of stuff, as well as the downstream consumption. The end business user, what are they trying to solve through the development of these ML and AI capabilities, and how do they consume that? Traditionally, this is hard because there's various kind of siloing of the underlying data, the processing environments, the runtimes, all that kind of stuff associated with the end-to-end workflow. Data fragmentation is typically the most obvious source of that siloing. This is largely where, of course, if you're a Snowflake customer already today, a huge kind of value proposition for us prior to even getting into the fancy machine learning and AI and exciting stuff associated with it. Just accessibility, usability of data makes kind of the end-to-end process associated with this extremely difficult. Not to mention, even if the data is accessible and available, once you have it, you need to process it in some sort of complex way when it comes to machine learning and AI. On top of that, the tools, processes that your data scientists use compared to your ML engineers, compared to your downstream business analysts maybe who are on the consumption side of these capabilities, are all vastly different. They look different, they serve different purposes, they have different feature set, they're in different ecosystems, and this traditionally is responsible for that sort of gap between really just the lack of return on investment that a lot of organizations and companies face when getting into data science, machine learning, and AI. With Snowflake and Snowpark ML specifically, we're looking to ultimately bridge those gaps. From the bottom up, of course, you're very familiar with Snowflake's kind of unified governed access to data, the ability to store not just your structured and semi-structured data, but now also unstructured data, integration of third-party and organizational partner data sources through the marketplace, and so on and so forth. Many of you likely have already been experimenting with Snowpark for Python, and all that opens up from a kind of processing framework point of view. You heard this morning also about Snowpark Container Services, which are going to further expand the kind of compute that's accessible to users and to customers by incorporation of GPU-enabled compute resources, containerized workloads, and so on and so forth. But all of that ultimately bubbles up and is exposed through Snowpark API constructs, right? Whether it's the data frame API for traditional kind of data engineering, but also now moving forward, Python APIs for task and DAG operation and management. Those are still really interacting with sort of core Snowflake database and Snowpark compute constructs. With Snowpark ML, we're exposing a higher level of abstraction to the data scientists, the ML engineer, the business analyst, who's a downstream consumer of a lot of this work, that rides on top of these same core kind of fundamental Snowflake capabilities, but offers an experience for development and operational management of ML and AI resources in something that's more familiar, right? When I first started working with customers using Snowpark to do machine learning and AI a year and a half ago, there was a lot of complexity associated with it. It was incredibly powerful. The stuff that our customers were doing was impressive, nonetheless, through stored procedures and UDFs and so on and so forth. But for the data scientist who doesn't know database concepts or things about stored procedures and UDFs, there was a lot of sort of mental gymnastics just to get in sort of the mindset of how to build ML with these constructs. Now with the feature engineering and modeling APIs in Snowpark ML, as well as the incorporation of a native Snowpark Model Registry into Snowflake, DAG and task APIs for orchestration, the entire sort of life cycle from development to production for machine learning and AI on Snowflake looks and feels like what it's supposed to look and feel like for data scientists and ML engineers. With that, let's take a closer look at it here with an actual demo where we're going to be showing end-to-end machine learning and data science using Snowpark ML. Beautiful. So we're going to take a look at using Snowpark ML in a Hex notebook to build an end-to-end machine learning pipeline going through data preparation, feature engineering, pre-processing, model training, model versioning and registration, automated deployment of that model for downstream consumption, and orchestration of that daily inference task using the new Python task and DAG APIs. We're going to run this in a Hex notebook. Great partner of ours. You got to see a lot of them on stage this morning during the keynote as well, and I'm sure they're either in this room or next door. There's Ariel in the back waving, the Hex team back there. Thanks, guys. So the first thing we're going to take a look at is, of course, just creating our Snowpark session. If you've worked with Snowpark Python already, a lot of this is going to be familiar in terms of connectivity to Snowflake, usage of the data frame API, and so on and so forth, to ultimately push down compute from our development environment here in Hex to your Snowflake compute resources. We're going to take a look at using, again, the pre-processing libraries of Snowpark ML, the modeling APIs to do model training, model registry for model versioning and deployment, and then as well as orchestration through the DAG and task APIs. The example use case is your classic Kaggle fraud detection, everybody's favorite machine learning trial sort of demo and use case that we've all probably done 100 times or seen 100 times in some sort of capacity. But to get started, we're just going to use the Snowpark data frame API to get an initial kind of set of data constructed, some of our different data sets in Snowflake joined together. In the case of fraud detection, we're going to join up data sets associated with the user account info as well as the individual fraudulent, non-fraudulent transaction information. To do that, we use our Snowpark data frame API, which again, many of you are likely familiar with already, to reference those tables inside of our Snowflake account, add some additional columns like parsing of certain fields, extracting hour of day, month, date, et cetera from timestamps, as well as then ultimately joining our transaction and account information. Our account info has things like individual or daily transaction limits for different users, which we're going to use to normalize, calculate and then normalize a sort of utilization feature against their transaction limits as a potential indication of fraudulent activity, among other things. So this initial function here, standard Snowpark data frame stuff. Very exciting, very cool, very powerful. Nothing new on the ML front though. Once we get to that joined data set though, standard pre-processing tasks like scaling, one-hot encoding, and things like that are going to be relevant for constructing the input features for our actual machine learning model. That's where Snowpark ML comes into play. Snowpark ML is installed into your Python runtime just like any other Python library, just like Snowpark. In fact, Snowpark ML, which is the pre-processing and modeling APIs, are now in public preview as of today. Model registry is in private preview. It's already natively available in Hex for you to start using, just like Snowpark. We're going to import the pre-processing module first. One thing that you'll notice as we go through this is that syntactically, we are nearly identical to your standard scikit-learn, XGBoost kind of frameworks for doing this work traditionally in a standard Python environment. So while the import statement changes slightly, we're importing snowflake.ml.modeling.preprocessing instead of scikit-learn.modeling.preprocessing. Syntactically, once we have those objects and APIs in place, it's going to look and feel identical. So in the case of pre-processing, maybe we want to do some min-max scaling or some one-hot encoding on specific features. We just initialize those preprocessors, the encoder, the scaler, the same way you would if you were using the native scikit-learn components. We call the standard .fit operation against our Snowpark data frame, not a pandas data frame, which is the key difference, of course, from how you would do this in a local Python environment normally. And then once we call that .fit operation, we actually get returned Snowpark ML preprocessing objects, which we can then leverage to transform against other data set to ultimately calculate those end features, right? These, of course, can also be wrapped up in a pipeline object or construct, the same way you would with scikit-learn as well. But you can, of course, just call the transformation methods directly against some input data set. The result of that is, of course, we get our one-hot encoded feature sets, but we also then get things like our normalized transaction data, you can see here in these two columns, which are the byproduct of our scaler, which we fit and then transformed against our data set. Again, when we call both the fit and the transform methods, 100% of the work and compute associated with doing that is pushed down to Snowflake and occurs on Snowflake compute resources where the data set resides. I worked with some really creative customers who were doing this with Snowpark Python themselves a year and a half ago, which was really impressive and cool. The difference is today, you have an API that exactly mirrors how you're accustomed to doing this as a data scientist or an ML engineer, where all of that complexity is totally abstracted away from you. You get the best of Snowflake's scalable and distributed compute. You get the best of security and governance with no data movement. But you get to do it in the way that's very familiar, exactly how you're accustomed to. Once we have those traditional kind of pre-processed features and so on and so forth, we get into that model fitting stage of the process. So consider just our input features here of our normalized transaction data, some customer loyalty features, some time, so on and so forth, and then we have our fraudulent transaction label to go alongside of that. Before we get into model fitting, you might also want to do things like metric or statistic calculations against those data sets. So things like correlation, coefficient calculations to determine if there are linear relationships between your input features and your output features. Snowpark ML's got that too. Within the metrics module, you can do things like import the correlation function, run that against your Snowpark data frame, where again, all of the work to do that correlation calculation is pushed down to Snowflake compute resources. No data leaves your Snowflake environment, but you get the same calculations you're accustomed to in a highly scalable, highly performant, highly secured manner. And once we have our coefficients, you do your typical visualization or so on and so forth that you're accustomed to doing. In our case, not so many good linear coefficients, so we're going to look at using something like a tree-based model, in this specific case, XGBoost, as our underlying model framework for doing our fraudulent transaction detection and classification. The two commands that every data scientist knows or every data scientist learns when they first start working with Python, model.fit. That's all it should take to train a machine learning model, right? You initialize a model object with some parameters. Maybe you're doing grid search and things like that for some hyperparameter tuning, but ultimately it comes down to model.fit to run your machine learning training algorithm and produce the underlying model weights and so on and so forth associated with that particular model. With Snowpark ML, that's exactly what the experience looks like now. Again, we're importing from the modeling module within the Snowflake ML Python library. We're going to import our XGBoost classifier, initialize that XGBoost classifier with some information about the input and output features of the data, as well as specifying some specific hyperparameters like the estimator count, learning rate, so on and so forth. Importantly, Snowpark ML's modeling frameworks support all of the optional parameters and keyword arguments that the underlying native Python library does as well. So any optional parameter you could specify to an XGBoost model, you can specify to a Snowpark ML XGBoost model as well. And the same is true for any of the scikit-learn estimators or LightGBM estimators as well. From there, model.fit against the Snowpark data frame. Again, no data local in my Python runtime here whatsoever. I'm just triggering the execution of this model training job to happen on Snowflake using the same syntactic commands that I would if I was running this anywhere else. The result of that is my actual model artifacts, which again are Python objects. They're Snowpark ML Python model objects that have both the information about how to interact with Snowpark components as well as the underlying pure Python machine learning library kind of components associated with it. So all of the methods, arguments, parameters, et cetera, that are associated with a traditional XGBoost model in Python, you can extract that same kind of data and information from the Snowpark ML object. Of course, with any of this, we're going to also then do some evaluation kind of metric calculation, do things like return our accuracy score, F1 score, maybe a confusion matrix and things like that. The thing I want to highlight with that is with our test input data frame, we can simply take the Snowpark ML model object. So again, this is a Python object in my Python runtime here that's really referencing the Snowpark ML object that is ultimately like executing and doing work server-side inside of Snowflake. But I can just call model.predict against an input Snowpark data frame and get 100% pushdown of that batch scoring operation onto Snowflake Compute, distributed across virtual warehouse resources, just like you're maybe building already with Snowpark Python today, or certainly that you're accustomed to with running SQL in Snowflake. Again, the huge benefit here is that this actually mirrors how data scientists and ML engineers write this code already today, totally abstracting all the complexity of the associated processing that comes with it when you're talking about doing this in a both secure as well as distributed kind of environment. That gets us to Snowpark Model Registry, which is the newly announced PRPR feature for logging, tracking, versioning, and deployment of model artifacts, all natively inside of Snowflake. Registry is backed by various tables, stages, schemas, and so on and so forth within your Snowflake account, but importantly, you as a data scientist or an ML engineer interact with it through the Snowpark Registry component itself. Just doing things like log model, right? Create the registry, log a model, that creates a new record inside of the model registry with associated tags, metrics, parameters, descriptions, versions, using whatever semantic versioning kind of construct you're familiar and comfortable with or that your teams use. And then making those all directly accessible, queryable, discoverable, secured, governed. So if I now go through the models that I've trained, I've logged them to registry, I can go ahead and list those models and visualize that my underlying machine learning models for my fraud detection XGB use case, we see all the various data associated with that. The model versions, a description, corresponding accuracy, F1 score, confusion matrix type metrics, tags if we wanted them, the time at which the model registration into registry occurred. All of that kind of data is available natively in Snowflake, supporting the underlying model objects themselves. And importantly, any actions that are executed against the model registry are tracked and made accessible from a traceability and lineage point of view. So if you have users that are updating descriptions or tags on model artifacts within the registry, you have not just the registry reflecting those changes, but also a full kind of lineage and traceability of the actions performed. So you can audit what activities were done, what things were changed, updated, modified, deleted, added, so on and so forth. Importantly, once I have a model in the registry as well, I can basically use typical Snowpark data frame syntax to query out what is the version number for this particular fraud detection use case, the model version number that gave me best performance according to a particular metric or score. In this case, I'll use the F1 score. That determines that version 5 is my optimal model. Now I can create a model object that's a reference to my V5 model in the registry, and also, through a simple model.deploy statement, push that model for inference as a user-defined function onto the Snowflake virtual warehouse. This becomes now something that I can simply call, again, model.predict, or explicitly call the named user-defined function, fraud detection, XGB demo UDF, in any sort of inference use case, and I get fully parallelized scalable inference from that machine learning model, tracked in the registry on Snowflake Compute without data leaving, mirroring the exact same sort of deployment process and framework that you would use using any of this other sort of MLOps tooling as well. So again, I can just do a best model.predict that's now been deployed into the virtual warehouse, and that gives me my inference result against a particular Snowpark data frame right there. I'm at time, but I'm also speaking next, so I'm going to use my speaker's discretion here to go over by just a minute to cover also then our DAG and Task API, which is coming out into private preview momentarily. momentarily is the wrong word. In a few weeks is what I meant to say. What this allows you to do is use typical task and DAG constructs that you're used to in a number of other sort of orchestration frameworks to leverage tasks and DAGs inside of Snowflake as well. So typically in the past, tasks and orchestration in Snowflake has been managed through exclusively kind of SQL-based operations, right? Which for DBAs who are managing those sorts of pipelines makes a lot of sense, but for the ML engineer operationalizing machine learning models is maybe either a foreign concept or certainly is not sort of the world in which they would typically operate. With the DAG APIs now, for Python specifically, you do DAG construction, task construction, and then DAG dependency operations, all using kind of common syntax and language for doing that. Taking our feature creation functions and our inference calls to our deployed machine learning model and ultimately packaging those up and scheduling that pipeline to run on a regular basis as an actual DAG in my Snowflake account. So I don't have to think about doing create or replace task statements and things like that that you would be doing as a DBA working on Snowflake. I have the same kind of DAG style task API calls that I'd be accustomed to using, again, in any other sort of orchestration framework. Ultimately creating these underlying DAGs, scheduling them, triggering their execution, and so on and so forth in Snowflake on a daily basis, say, for a typical batch ML use case or something like that. So I will wrap there. Again, we're really excited about what we're building with Snowpark ML. Hopefully for the data scientists, users, and ML engineers in attendance, this looks and feels like something that you're excited to use and get started with. And hopefully it's expanding kind of what you think is possible through the usage of Snowpark Python, and especially now moving forward, Snowpark Container Services as well. There's a number of other related kind of features on, or sessions on feature engineering and feature store over the next few days. Venkat and I will also be running another 45-minute version of this session where we'll go into a little bit more detail tomorrow afternoon over at Caesar's Palace. And with that, thank you for being here. I will open it up for a few minutes of questions if anybody has any.